Hi, we continue 7.4 ordinal multinomial responses. So in the previous slides that we have discussed basically the logistic model. So proportional odds model is based on logistic link, and also the generalization uses logistic link. But we don't really have to use the logistic link. So one natural choice is the phi inverse. So the link function g can be replaced by inverse of standard normal cumulative distribution function. So phi is the standard normal cumulative distribution function. So if we have the standard normal distribution, then if this is x, then this area is the phi of x. So inverse of this is actually inverse CDF. So the phi is from negative infinity to positive infinity to 0, 1. So this the phi inverse is 0, 1 to negative infinity to positive infinity. So that means that we map the gamma j to the real numbers, a set of entire real numbers. So the theta j minus beta transpose x, this is the same as the proportional odds ratio. So right-hand side can range from negative infinity to positive infinity. So this is the phi inverse, the link function that works well. Yeah, so phi, the benefit is this is the probabilistically more natural choice. For example, the more advanced model, such as the multivariable response, probably we have maybe the two multinomial responses, or maybe two ordinal responses, such as the two different movie rating variables or something like that. So in such a case, it's easier to use the normal density function to generalize it into multivariate case. So multivariate distribution, besides the normal distribution, it's really hard to extend, even the t distribution. Multivariate t distribution, how to define it? So it's not that simple. Yeah, so there's some benefit, but the downside is calculation. So the phi inverse doesn't have a specific analytic form. So maybe it takes more time to calculate this, the value of this function. Okay, so the code, the R code. So we use the same data set, the presidential election 1996 data set. And the party is the ordinal variable with 3 possible levels, and the income is numeric variable. And we can just specify method is equal to probit. Then we can estimate the model. And you can see that these numbers, so these numbers has been changed since the last time. So if we use the multinomial, the proportional odds model, then that the coefficient was 0.209 and the 1.292, and also the income. So this part is the 0.01312. So these numbers are different. Okay, at least the signs are the same, and at least the second coefficient is larger than the first coefficient, but the numbers are different. But this is because the model uses different function, so it doesn't really imply anything. And actually, the t values, so this has more meaning. It will it shows how significant the variable is. So these are actually similar. So this was actually the 6.54 previously, and this was previously 1.86, and this was 10.76. So these are similar. So essentially it's similar. And if you calculate the fitted values of the two models, the proportional odds model and the ordinal probit model, actually these are similar. So okay, so this data set has 944 observations, and Actually, it's sorted by income. So if we choose, excuse me, the first, second, third observation, those are similar. So we picked up first 500s and 900s observations. So if we pick up these different observations, actually these probabilities are similar. You can see all probabilities are very similar, maybe only the difference of up to maybe 0.6%. So these numbers are very similar. So even though the functions are different and the estimated coefficients are different, essentially these models are similar. What's the difference? It depends on the data, which model is better. But generally speaking, the logistic link is more robust against outliers. And so if we have outliers, then it's better to use the logistic model. Probably the result is more stable. Or even you can use the quotient link, then the result is even more stable. But usually it's a little less efficient. Often it's less efficient. So it depends which is better. Which is better depends on the data. Yeah, and we estimated probability, but of course we can calculate this from scratch. So this is our theta j minus the beta transposed x. So if we multiply phi, then we can calculate estimated probability. And remember that this is ordinal model. So we calculate probability of them. Them is actually the 1 in the ordered variable. And independent is 2 and Republican is 3. So basically we estimate this probability of them and probability of the them or independent. So these are calculated by these two ones. And the phi is the normal probability function. So you can just use the p-norm function. That was originally the I-logit function in proportional odds model. So to calculate probability of the independent, then we can just take the difference, p of them and indep minus the p of them. And probability of Republican is 1 minus probability of Democratic or independent. So again, that we calculate the probability, then we get actually the same answer as previous page. Yeah. Okay, so the next model is the ordinal ordered the complementary log-log model. So link function G was the ordinal, the probit function in the previous one, but here the G is the so-called the complementary log-log function. So it's a little bit hard to interpret, but this is asymmetric distribution which appears in the extreme value theory. And again, the formulation is the same. And the formula, the R code is also basically the same. So just you can specify the method, the complementary log-log. Then we can see the intercept and the values. The values for theta 1 hat and theta 2 hat. Yeah, it sounds the t-values a little less significant. Maybe the first one is more significant, second one not significant, but maybe this is more important, and the 5.927. So compare with the previous one, so 6.775, so the slightly less significant. Yeah, and you can actually also compare the AIC and the likelihood function, because this is the likelihood-based method. And previously, the residual deviance, it was, I think that 1994 or 1995 for the proportional odds model and ordered probit model. So that actually gets worse. And AIC also gets worse by about 10. So for this specific data set, the ordinal probit and the proportional odds model are better than the complementary log-log model. And the fitted value, and actually these are very similar to the other two models. So we cannot really distinguish with these fitted probabilities, but probably the performance is a bit worse than the previous two models.